Moving on into 8.4.1, our second part is we're still looking at the hyperbolas that are centered at the origin, but now we're going to talk about how to graph them. So we looked at that shape and the equation here, but to how to get the steepness of this curve, how to get those asymptotes, we didn't talk about that yet. We talked about how A is the denominator under that leading term, and how foci is the C. But how do I get the shape of the curve? So the shape of the curve, we use A, which we already talked about, and the B, which is under the second term, to get this box. So the B, or the square root of the denominator under the y, is going to determines that height of that box. And the A determines the width of this box. And once you get this box, then your asymptotes you draw from corner to corner through that box, and that guides the shape of the hyperbola. So let me go through those steps more carefully. So the first thing we're going to do is identify the center. So right now in 8.4.1, we're looking only at the center being the origin, so that part's pretty easy at this time. So we're going to identify or plot even center at the origin. And then once we have that origin, I want to look under I see that I'm going to go in the horizontal direction because the x is the leading term. And under my x, I have a squared. So a tells me where my vertices are. Right? From that center, I count forward a and backward a, and I plot these two vertices. So the second thing I do is plot the vertices at plus and minus a, in the direction of that first term. In this case, that's the x term. So I have my center. I plot my center. Then I plot my vertices. So I got a here and then minus a there. And the next thing I want to do is actually draw that box. But to get that box, so I have the width of that box when I plot the A's, but I still need the height. So to get the height of the box, I'm going to plot the other vertice, what would be a vertice, like for example in front of ellipse, or if it was a vertical hyperbola. So I'm going to say plot vertices. So we're going to do plus or minus a, but we'll also do plus or minus b. And notice the b is in the y direction because it's under the y on this one. So I go plus or minus plus b here and minus b here. So now I have 4 vertices. And those vertices define the width and the height of this box. So I know it's, the height of the box is 2b high and 2a wide. So that's my next thing. My next thing is to draw the box. So it's 2 times a times 2 times b. So it's this. I'm actually going to draw a perfect box with my technology. Oh, that's way too big, isn't it? So I get that the B's give me that height and the A's give me the width. So I'm using those 4 vertices to define the box. And notice the vertices aren't in the corners. So you'll have to use your imagination to get that first point. Not your imagination, I'm sorry. A guide, I guess I should say, to get that first point going from the height here and the width there, starting there, and then you can get your box. So now you got your box. The next task is to draw in your asymptotes. So that'll be 4. You're going to add asymptotes from corner to corner of the box. So that gives us this line and this line. And again, that's not part of the graph, that's just guiding the graph. The black branches are the only part that are really part of the points of the hyperbola, which is what we'll do next. So now we have our asymptote. We have our asymptotes, we have our vertices, and we have, we know it's going to be the transverse axis is the x-axis. So we're going to go opening left and right because we're starting with the x. Now we can, actually, so first thing I did was identify the direction. So I had a leading x, which tells me open left. It opens left, right. If I had had a leading y, then I would open up, down. But I have a leading x, so it opens left to right, left and right. And then I want to draw the hyperbola starting at the vertex. And following those asymptotes. So those asymptotes define the direction of the graph, but remember, asymptotes never touches. So we started our vertice, and I like to start at one end so it's more curvy than it is like if I do one branch at a time, I end up making more of a V. So I try to do the whole thing starting really close to that one asymptote, and then to the vertex, and then getting closer and closer to the other asymptote. And there's my one branch. And then again, starting at the tip really close to one asymptote, through the vertex, and then getting closer to that other asymptote. So there is that process for looking at graphing the hyperbola with a leading x. This is a horizontal hyperbola. But let's look at the vertical one. The process is the same. The difference is that when you do your vertices for step 2, you're going up and down to get to A instead of left and right. You follow the direction of the first term, which in this case is y. So that means it's going to be up and down. And for step 5, you see the hyperbola opens up and down. Okay, so that's a lot of talk. I'd like you to go to your textbooks now. And on page 659, you'll find example 3 with the video. So I want you to watch that video. And then after you've watched it, you've seen my step-by-step just a second ago. When you come back, then I'll have you try some more. So please pause this, go watch the video from the textbook, and then come back. Okay, so you've seen example 3, you saw my step-by-step on how to do these. So now I'd like you to try these 2 graphs, and you can try these on your own. So pause my video, try these 2 graphs, and then after you've given it a chance on your own, then come back here and we'll go do these together. Okay, so for number 8, we already have it in that right form. So it starts with the y squared, so this one must be a vertical, right? So my A's are going to be plus and minus. Up and down. Okay, so my first step was to plot that center. So the center is at the origin. Actually, you know what I'm going to do is I'm going to rewrite this equation a little bit so that my a and b is more obvious. So I'll write it as a squared, which is 12 squared, and b squared, and b is 5. That's the square root of 25. Just so my a and b really pop out. So my a is 12 and my b is 5. Okay, so then I can see that my center is the origin. And then from my center, I go, my step 2 is to graph the vertices. Since I'm starting with the y, that means my vertices for a is going to be y equals plus or minus a, which is 12. So I go up 12, down 12 to get my vertices. So it's 5, 10, 11, 12. That gives me my box's height. And then I also want to draw my other would-be vertices to get my box width. So that's plus or minus 5. That one really gives me my box width. So plus and minus 5 is here and here. I should say, yeah, I got x. Okay, good. All right, so now I got my all my vertices or would-be vertices. This, like if I was doing my ellipse, I would now draw my ellipse like that. But again, we're doing hyperbola. So you can see the beginning process is very similar. But instead of doing an ellipse, we're drawing the lines going away. So it's a difference instead of a sum. Okay, so that means we have our box, height and width. So I will grab my handy dandy box tool and do my box in light blue. Yeah, that's good. All right, so I think about the red one is 12 units high, the blue one is 5 units wide, or I should say from the center. So then my box is right there. Well, almost. Okay, close enough. Now the next task is then my asymptotes. We'll go through the corners of the box. So from one corner to the other corner, there's my asymptote. With a straight edge, you can draw this whole line at one time. With my computer tool, it's a little harder, so I'm going to do it in 2 steps. But with your straight edge, connect those 2 corners and draw on those asymptotes. And then my last step is to draw the curve or the branches. So my branches, I remind myself, okay, this is horizontal, right? I start with the leading y. I'm sorry, vertical. So the transverse axis is vertical. So it opens up and down. And I start at my vertex in the vertical direction. And I go up and down. So I start by the asymptote, go through my vertex, and then get closer and closer to that other asymptote. All right, start by one asymptote, getting then to the vertex, and then getting closer and closer to that other asymptote. All right, and there is my hyperbola. Now remember, the points of the hyperbola are only on those black branches. The other parts where everything else on this graph is just a guide. But the hyperbola is really just those black lines, the curves. All right, now let's go on to number 15. 15 is a little bit different because this time I don't have 1. Remember, our equation always has 1 on the right-hand side. Well, with 15, I don't have it equal to 1. So the first step I have to do on 15 is divide everything by 32. Which gives me 8 divided by 32 is 1/4, so that's y squared over 4. 16 divided by 32 is 1/2, so that's x squared over 2. And then 32 divided by 32 is 1. So now I'm going to deal with that equation. And I'm going to take it one step further so my a's and b's really pop out. And I get y squared over, to get 4, I take 2 squared. And to get 2, I'll take the square root of 2 squared. So that my a is, looks like a z, is 2, and b is radical 2. My center is at the origin. So I'll start from the center. And then my next step is to plot my vertices. My vertices are, I'm starting with a y squared, so they're going to be plus and minus, okay, are going to be in the y direction, so I'll go y equals plus or minus 2, plus or minus a, from the center, so that's up 2, down 2. So there's my vertices, and I'll also do my would-be vertices to get the box width, which be x equal whatever's under the x, which is the square root of 2. Plus or minus the square root of 2, that's about 1.4, so I'll go about there-ish. And then the next task is to draw my box. So my box is as high as the red dot and as wide as the gray one. So I'll start in this corner and then I get my box. And that box defines my asymptotes. So then I'll draw on my asymptotes from corner to corner of the box. Oops. Oops, went the wrong way. Okay, there's my asymptotes. And finally, I'll draw my branches in. My branches, remember I'm going to start at, it's the y's in front. The y is the positive term, so that means that the branches open up, down, starting at that vertice. So I actually like to start at the transverse, like the asymptote. So I can start really close to that. Oh, I don't like that curve. So I can start really close to the asymptote. I don't like that curve again. I'm going to just get rid of that arrow. So really close to that asymptote, through the vertex, and then get closer and closer to the asymptote. As the curve moves away from the vertex and up the asymptotes, it gets closer and closer to the asymptotes. So you can see this shape is more V-like than a parabola, but still not pointy like a V. It's still curvy at the top, at the vertices. All right, so that wraps up graphing at our hyperbolas that are centered at the origin.